Hello viewers, I Dr. Sanjay Upreti welcome you in the channel of Electrical Science by Dr. Sanjay Upreti. So in this video, I am solving this problem which was asked in the midterm test of electrical science paper and that conducted by the IP University. So this problem is involving a sources, independent sources and dependent sources both. So in this question, you can see the question is you have to find out the value of the VR. Then VR is the voltage drop across the 2 ohm resistance, and in this circuit there are the three sources. So the number first source is here, that is 1 ampere current source. Second one is a 2 volt source, and third one is a dependent source whose value is given by the 8 multiplied by the VR. VR is the voltage drop across the 2 ohm resistance. So and this question is asked to solve by the nodal analysis, right? So we will be using the nodal analysis. So in the nodal analysis, so that is the two nodes are given, x and y, right? So let us say this one is the voltage here is the Vx. Voltage of this node is the Vx. So we will apply the nodal analysis here. Let us assume that there are the three currents are flowing. First one is the I1, right? Second one is the I2, and third one is your I3. So by the KCL, the summation of all these three currents will be 0. That is I1 plus I2 plus I3 is equal to 0. So I1 is clearly given, that is a 1 ampere source, and that current is entering into the node, right? So it can be written as a -1 plus I2. So I2 current can be found out. The voltage here is the Vx, and this in this one it is a 2 volt. So it can be written here as a Vx -2 divided by resistance, and resistance here is a 2 ohm, plus I3. I3 is the Vx minus 8 VR. So Vx minus 8 VR and divided by 10 ohm resistance. So it should be equal to the 0, right? So let us first find out the multiply this equation by the 10. So to simplify this one, let us multiply it by this one is by 10. So it will give you the -10. It is -10 plus 5 into Vx minus 2 minus Vx minus 8 VR should be equal to the 0. Let us simplify this one. So it is 5Vx, and then you have a I think this sign will be plus. This is a plus sign, so this is a 5Vx plus Vx, so it will become the 6Vx minus 8VR. That is a minus 8VR. That is the -10, and then it is a -10. So that will be the -20, and it will be equal to the +20 if we take into the right hand side. So we have got this equation, 6Vx minus 8VR is equal to 20. Now let us find out how the Vx and V are related. So from point X to Y, the voltage here is a Vxy. Vxy. So here you can see between the X and Y, this voltage VR is here, and the 2 volt source here is here. So Vxi will be equal to VR plus 2, right? And Vxi is the Vxy is nothing but a Vx minus Vy. It is Vx minus Vy is equal to VR plus 2. Okay. So this is a reference node here. So voltage of here, this Vy is equal to 0 here, because we are measuring all the voltage with respect to this Y, or Y is a reference node. So this Vy will be equal to 0. So that will give you the Vx equal to Vr plus 2. Now we have two equations. Number one equation is in the Vx Vr. Second equation is here. So if we put Vx equal to Vr plus 2 in this equation, so it will give you the 6 into Vr plus 2 minus 8 Vr is equal to 20. So it will become 6 Vr and minus 8 Vr. So that will give you the minus 2 Vr, and 6 multiplied by 12, and if you transfer it to the right hand side, so it will give you the 20 minus 12, or it is equal to the 8, right? So this will give you the Vr as a 8 divided by minus 2, it is equal to the minus 4. So value of here, this Vr value of the Vr is the minus 4 volt. So that question is that question was looking very complex, very tough, but in fact this is a very easy problem. I hope this my explanation will help you to solve such problems. And if you are like this video, hit the like button and subscribe the channel. Thank you.